Hello and welcome to this Friday where we are starting our live sessions with a discussion on fractions. Now, I did remind you to have a look at the schedule and see what is on the menu, especially this week with midweek holiday and some self-paced sessions. We, not we, I hope that you did do the first part of fractions. That mainly just introduces how we are interested in looking at fractions. It's not about the calculation as much as it is about, sorry, I'm just multitasking here, as much as it is about focusing on that very first introduction to fractions. All right. Please remember to mute your mic, otherwise I'm going to mute it, and I might forget that I did that, and then you can't ask any questions anymore. And I don't want that to happen. I want you to ask your questions. Let me just get my setup ready here. My cable is in a weird position. Come on. Nope, that's not it. Mm. Hold on. Technical difficulties is always a lot of fun. My tablet is on the wrong screen. Okay, that should be better now. Okay. So we're looking at fractions. I have a different setup today, so I'm trying to get used to it. So remember that we are, everything is sideways. That's fun. That we are working on the left here, where our understanding is as basic as it can be with the topic. I I like to use the word intuitive, but I mean it depends on the topic. If you move chips around to do integer calculations, that's pretty intuitive. It's pretty basic. It's an introduction for sure. And that's where we want to be with our fraction discussion as well. Knowing that or understanding that we do have more experience with fractions. Well, most of us. And we can do things in a more efficient way. Certainly, when numbers get bigger, things get a little more complicated, you would naturally or sort of be forced to drift towards using certain properties, being more efficient in those calculations that require it. But the very first step should never have those things. So think about when we do basic integer calculations, we can use the number line model or the chip model. There are no other shortcuts there. But the numbers are so small that we don't need them. It's the very first step. So we're going to do the same thing here. And we're going to focus mainly on the arithmetic. And in this case, we're going to do all of them. We're going to do addition, subtraction today, hopefully. And then next time we have multiplication and division. And we're doing them in increasing order. So they do get a little bit more complicated as we go. But the first two is still a part of our introduction and shouldn't be overly complicated. I just want to get used to how we are going to, what we're going to focus on, how we're going to do it. So let's take an example. let's maybe say, actually, I'm just going to do it by way of the book exercises. I think we're over here. I need to drag it over to show you. Let's zoom in a little bit. There we go. So, as I've said in the previous video, though you can use other shapes like circles and talk about pizza wedges and things like that, pizza slices, wedges on a circle, to me, it's a little bit tricky to draw accurately and consistently, so I prefer a rectangle. So the question will maybe say use a rectangle diagram, but feel free to use another shape if you prefer. Just use a diagram, use some geometric shape to explain on the very basic level how fraction addition is done. So this is now like the number line model or the chip model. We're using the specific method to explain how to get the answer of those two fractions added together. So we have 2/3 and 1/5. Okay, let's do it. So 2/3 plus 1/5. Now it's not the number line of the chip model, but it's sort of at the same level. That's the key, the level. Okay, so I am going to take a similar approach. The first number is how much I have, and I want to illustrate that with my rectangular pizza. Then I just choose out of habit to slice this up vertically according to the denominator, which is 3. And then we have 2 of the 3 slices. Let's color that pink to represent what we have. Okay, now I'm looking to add. So I want to put that together with, actually I could have done it over here. Let's do it like that. We have space over here. We have the space, why not? So together with another slice of bread or pizza or whatever. So let me slice that according to the denominator for that fraction, which is 5. They're not equal slices, but as long as you get close, right? Try and get as close as you can to make them the equal size, but clearly it's not going to be perfect. It's okay, especially with the 5. So let's color that maybe blue. I only have 1 slice. Oh, not a lot. Yeah, I only saw your question now, sorry. Um, whether you were taught like this or not is, at the risk of sounding cold, irrelevant. I wasn't taught like this either. And what most teachers do, because fractions with word problems is one of the topics that people are most fearful in teaching, they try and get through it as fast as possible. So they go to the shortcuts, just write a common denominator and get the answer. Don't think about it, just get the answer. Because as soon as you think about it, little Timmy, you're going to ask me questions, and those are going to be questions that I'm not ready for, and I'm anxious about that. So let's just get through this as quickly as possible. That is obviously not what we want to do. We want to build a number sense with fractions as well, just like we did for integers. You take the time, you move your base blocks around, you move chips around, you walk along the number line. You give so much time there, but you're not fearful of that. It's pretty simple. So if Timmy asks a question, there's not much you can ask that's going to catch you, or that you're not going to know how to respond with confidence. Yet with fractions, there's a lot more happening here. And that makes it to me even more important that I want to build a number sense, visualize these things when they're small, get a sense for the size of different fractions. Visualization is such an important thing. And then, yes, when they get more complicated, just like with the integers, when they get bigger, I'm going to have to use properties, shortcuts. Two negatives make a positive. In case of fractions, common denominator. But with this, I can explain why that common denominator method and shortcut will work. It's not my starting point. It's when I when I have to move a little bit to the right. I always start on the left, but as a teacher, I have to be comfortable starting on the left and handling all the questions. And you'll see with multiplication and division, it gets a little tricky to stay on this left, but it's still a very good thing to do. I can easily go on a rant for 30 minutes, so let me try and contain myself here. So I know how I need to combine these two quantities. I see the two quantities, but they are not quite comparable because their denominators aren't the same. To compare fractions, we have to uh, make them comparable by making them equivalent to the same amount, but with a different denominator. So what we're going to do is, for the pink one, take the other denominator and split and cut that bread, let's call it bread, cut that bread horizontally into 5 slices, like this maybe. Not blue, no. That'll just be confusing. Now I'm trying to make these as even or equal as possible, pretending that they're equal, right? It's never going to be perfect. And for my second amount, I'm going to use the first denominator to split that horizontally, so that'll be into 3 slices. So yeah, and while I'm thinking of this, because you are not perhaps familiar with this and it takes some time, absolutely ask questions. Let me know if you have any issues, like what did you do there? How does this work again? Could you repeat this? Well, we're going to do a good number of these. And next week we can have a review as well. So on this first amount, I see now I've broken it up into smaller pieces, but now these pieces are comparable in that perhaps they don't look like it, and we can look at some variations as we go to the next example. A piece like this and a piece like this, they have the same size. Why? Because my standard rectangle is split into 15 pieces, and they're all the same. And this is 15 pieces, all the same. So those two cover the same amount of bread, if you will. So in the left, I have 1, 2, 3, 4, 5. I have 10 of these pink pieces. Now I don't want to rush through this just to get through a lot of examples. We'll have time next week. I'm going to go at a pace that feels good. And of course, I have to put that together with only 3 of the blue ones, right? Only 3, not a lot. Now, a question might be, for little Timmy, these don't look the same, yet you just put them together. The whole issue was that I can't put things together if they're not comparable. Yes, so let's see in the next example, if he doesn't like the fact that I split a standard rectangle into the same number of pieces, therefore an individual piece has to be the same. If he doesn't like that, we can modify this, and we'll do that in the next example. So I have 10 and 3. So let's say our result, or that's the results in 13 pieces. So in our first attempt, which there's nothing wrong with, it might raise a question, these pieces don't look the same immediately. Okay, so let's keep that in mind. So now I have the sentence. What I've done here, and you'll see this theme carry through to the other operations as well. What we do essentially is take a fraction calculation and translate that to an integer calculation. I took these fractions and I transferred them to 10 plus 3, which I'm much more comfortable with, of course, and I got 13. Now I have to go back to a fraction answer. So I have 13 pieces, and that's, in terms of a fraction, going to be relative to a standard rectangle. So for a standard rectangle, I can look at any one of them, just don't look at the color, and I can say it takes 15 pieces, whether they are more square-like or more flat. It takes 15 to fill or make one whole rectangle or pizza or whatever you want to call it. I now have 13 out of the 15. So we end with 13 fifteenths. You can stop there, but remember, attached to a fraction, it's always of a whole. Rectangle in this case. We don't always say it because it's always there, with some exceptions later. Standard sentence, it's always in reference to something else. Whether we say it or not, a fraction does not stand alone, ever. It's always attached to something. I have 13 fifteenths. Okay. Of what? Of a pizza? Of a loaf of bread? Of some standard unit. Okay. So we want to have words, write out sentences, but you have flexibility in terms of how you want to arrange these, which sentences you like to make it as clear as possible for you. Definitely diagrams, definitely some sentences, but you have some flexibility. So let's see how we can alleviate that potential question that little Timmy might have because the pieces don't look the same. And we can do that with our next example. 1/4, 5, 6, 1. Oh, no, we already have the number, right? That's number 2. 1/4, still adding, just different fractions. So let's practice this. So I have, and addition is first because it is the easiest one, right? Just like merging some chips, it's the easiest integer calculation as well. So let me have my fraction, my first loaf of bread or whatever, and I'm going to split it into 4 vertical slices. I'll fix that line in a second. My lines don't always extend. There we go. And I want to indicate with color how much I actually have of that bread. I only have 1 of the 4 slices. That's okay. I want to put that together with, because I'm adding, another portion of another loaf of bread. Let's split that into 6, but now looking at the previous one, I realize that I am potentially going to confuse little Timmy if I go vertically with the other denominator. Then when I go horizontally with different denominators, the little pieces, though they are equivalent, they won't look the same immediately. So what I could do is go horizontally in this one in 6 slices. So halfway, and then split each half into 3. Knowing that, well, I'm going to do that with the other one. So let's have the number of lines in both directions the same. It doesn't actually matter how I cut the bread, right? It's a little unconventional to cut the bread along its length, but I can do it. And I have a lot of these. I have 5 of these slices. Very nice. Like so. Now, they are obviously not comparable, so I'm going to take the first and split it according to the other denominator in the manner that I haven't done yet. So it'll be horizontal lines, and it'll have to be 6. No, not a little line like that. Come on. Try to make them as equal as I can here, but it's gonna fail sometimes, but it's pretty close. And then for the second amount, I'm going to split it into 4 slices. Of course, the opposite way of what I have so far, so vertically. And I can totally explain why I'm doing that. It's to avoid the visual confusion that they might not look the same, right? They definitely are in both cases, so you don't have to do it this way. Okay, so now let's convert, not pink. Let's convert this to an integer calculation. How many do I have here? I have 6. I have 6 pink pieces. Together with a lot. I have in a row 1, 2, 3, 4. I have 1, 2, 3, 4, 5 rows. Now, it depends on the audience that I can say 20, or for grade 1 Timmy, no, not, I won't do fractions for grade 1, but for a younger Timmy, count them one by one, whatever gives him confidence. But you can do a quick multiplication to save some time if you want to. Know your audience, know your audience. Okay. So I have 6 of one, 20 of the other one. So obviously together it is 26 pieces. Blue, pink. Now they're merged. Now I just need to put that in context compared to a standard whole rectangle. So the sentence that you'll always see us writing is this guy. It takes a certain number of pieces to fill or make one whole rectangle. That's always going to be a sentence I want to write. The numbers might change, but the sentence will always be the same. It takes, in this case, 24 pieces to fill a whole rectangle. You can count them. You can just say, oh, it's 4 times 6 every time, right? 3 times 5, because I split it into 3 one way and 5 the other. Split it into 4 one way, 6 the other. It's always going to be the product of the two. But I'm not looking for shortcuts in this stage. As annoying as it might be for you, Timmy might need you to count them one by one, to draw another rectangle where I don't see any color. All those things you might need to do. Regardless, you get to 24. So that'll be my new denominator. And I have 26. So we can make one whole with 2 pieces left over. And therefore, we have 1 and 2 24ths of a whole. Simplification is not a part of this. It's a different question, though you could argue it is on the left. I argue simplification is a little bit further in. Common factors and canceling and all kinds of stuff. That's a little further in. That's a shortcut. So, though people are obsessed with simplification, I personally I don't want to see simplification here. Yes, you might know that's 1 over 12, but that's not the goal here. What is wrong with 2 over 24? There is nothing wrong with it. But we're so conditioned to simplify everything we see. It's silly. It's busy work. It is not necessary to simplify anything. You might simplify stuff that you need in a future calculation. Sure. But that's the end. This is my answer. There's no need to simplify this. And that's not a part of this basic method. Simplifying moves me to the right. Even a little bit. I want to be on this left and build a number sense for fractions. Simplification is going to require a shortcut, canceling the twos and stuff. Those are shortcuts. Those are properties of fractions. And that's not on my intuitive left side. So I ask every time, don't simplify it. But if you really have a compelling urge, you have to write the answer is 1 and 2 over 24 because that comes from my quantities, my sentences, and everything. If you then feel I need to simplify, must simplify, then after that, fine, I'll look the other way. But that's not technically a part of this question. All right. We take as long as we take. We might not get through fractions, subtraction of fractions, but let's at least see one of the other ones. We had nice small fractions. Let's at least see uh, one of the other two. I don't think we need to do all of them when it comes to addition, but let me know if I'm wrong. What we want to do is a mixed number. Let's do number 3. It really doesn't matter what's mixed and what's not, right? There's something with whole portions as well. I don't know if I have enough space. I'm not going to risk it. Okay, what was that guy? 2 1/4, 2/3. 2 1/4 plus 2/3. And if you do the other one, try it by yourself. Send it to me if you're not sure. But I think with 3 examples, we should be okay. Everything is the same. I just have a bigger diagram. So my layout might be a little different. I have 2 whole pieces of bread, whole loaves of bread, and then a little portion of another one. So because the first 2 are whole, I don't need to split them up necessarily. And at this stage, I certainly don't have a need to create more lines than I need to. But the last one I definitely do. So let's do that, and I just start with vertical out of habit. But it really doesn't matter. You could have started with horizontal. Doesn't matter at all. Regardless, I have one of those slices. Okay, that's what I have. Now I don't have any space, so I'm gonna have to, whoops, not in pink. I'm gonna have to put my my second amount at the bottom here. That's okay. It's not a big deal. I don't have a lot of those. I just need one rectangle, and I do need to split it up. Now, you decide if you like splitting them up in a consistent way, always vertical first, and then running the risk of just having the pieces not look perfectly the same, or avoiding that and having them look perfect from the start. Maybe the second one. If you can avoid questions that aren't needed, it might be better. So for thirds, I'm going to go horizontally from the start. No. so that visually my pieces will look the same and everything is just nice. And I have two of them. Okay, that's okay. It's not a lot, but it's not nothing. Okay. Now my goal here is exactly the same. However, because I am adding two whole loaves of bread, I'm never going to need to cut these loaves of bread. They're going to stay whole. I could create another whole loaf of bread if I have enough that I'm putting together, but the existing wholes won't change. So I can keep those. I never have to cut into them or anything. So let me just change the black here. For the portions that aren't complete whole loaves of bread, I do, however, need to split them up and compare the pieces. So I'm going to split the last pink one up according to the other denominator, which is 3 pieces, or slices rather. And the blue one, I'll split according to 4, the other denominator. So yes, it's time consuming, but I enjoy the drawing and everything. It's nice. I can use my space over here maybe just to have everything on one screen. I have 2 whole, I'll just say holes, rectangles. I mean, that's better. 2 whole rectangles and 3 little pieces that are pink. And I want to put together with that 1, 2, 3, 4, 5, 6, 7, 8. 8 of the same pieces. They are just blue. But when I put them together, I don't care about color anymore. So oops, not blue. All together, we get 2 whole rectangles, or pizzas, or loaves of bread, and 11 pieces. Now they're merged, so they're not pink, they're not blue, they're just pieces. Now I need to put this 11 specifically into context. How much of a loaf of bread is that? Standard sentence again. It takes, I can look at any standard rectangle that is split up to 2 ways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It takes 12 pieces to make another whole rectangle. And we have 11. So we have 2 and 11 twelfths. You don't have to write of a whole, but know that it's always there. So the fact that I have some mixed numbers to start with doesn't really matter. They are not going to ever change. They're not going to be broken up or anything. So I can just keep them nice and whole. All right. That is it for addition. In the interest of saving time, I'm going to skip the other one that we missed, the number 4. Nothing changes. Just draw them. They have a whole rectangle coming from each one. But so what? I just merge them and get 2 whole rectangles. And then see from the portions that are left that I'm merging, can I get another whole rectangle? And then update that accordingly. All right. But regardless, let me know if you have any questions. Now we might need to look at some subtraction next time as well, which after a weekend and a quiz on Monday and all kinds of stuff, it might be good to just start this and then revisit it and refresh our memory. So at the very least, I want to do one subtraction and then maybe have a little bit of time just to see if there are questions about the quiz on Monday. And if that is the first time you are hearing about a quiz on Monday, I'm sorry to surprise you, but it is in the schedule. We'll double check when we're done. All right, so we're just going to do the first one, and we'll leave at least two of the others for next week. 2/3, 1/5. So this is exercise 14.6. 2/3 minus 1/5. We're going to talk about the quiz after this one. All right. So I start with the first number, what I have, just like before. I don't have much, but it's something. I'm going to split it vertically into 3 slices. And then illustrate what I have. I have 2 of the slices. Not too bad. All right. Now, just like for the chip model, this is sort of the fraction version of the chip model without the negatives. It's all just positive pieces. But it is closer to the chip model. Just like in the chip model, I make a point to not write the second number or represent the second number extra, making it look as if I have more than what I actually have. When it comes to subtraction, the rest of it is merely an instruction for what to do with that first quantity that I have. I only have 2/3. The subtraction then tells me what to do. I need to remove something. So let's leave some space over here. Let's leave a line. Switch to black, definitely. And then say we need to take away 1/5 of a whole rectangle. The problem is, compared to what I see and what I have, I don't know how much to remove. I know I need to remove something. I don't know what to remove. So on this, we're going to draw our horizontal lines according to the other denominator, which is 5. Try and make them as equal slices as possible, but the 5 is always left with some bigger than the other. If you really measure, some are a little bigger, but it's pretty close. It's pretty close. So, looking at the pieces, let's just go. How much do I have? Well, I clearly have 2 columns of 5, so I have 10 pink pieces. 10 pink pieces. Now, it might seem a little strange. Do not draw the 1/5, but in my experience, I run into more problems and more questions, more confusion, because people see another fraction, another bunch of pieces, and they think they have more than what they need. And by they, I mean little Timmy. So now I understand what I need to do. I need to take away something. But what is that something? In reference to a whole rectangle. So I do have some options here. If I've trained myself to look at any rectangle that is split up into 3s and 5s and just temporarily not see pink. This is just a standard rectangle that can help me translate that last sentence I have. And for that sentence, there is no pink. It's not 1/5 of the pink. It's got nothing to do with pink. There is no pink in this bottom sentence. Now, if you need to, go and draw another one, split it up again, and do everything again. so that you don't see any pink. Or you can just train yourself to temporarily not see pink. And of course, that depends on your audience. With little Timmy, I wouldn't even try this. I would draw it somewhere else. Scrap piece of paper, somewhere else that I can throw away, just so I can translate the sentence and see, well, a fifth of a whole rectangle. How many pieces is that? It's one row out of the five. It's three pieces. So a fifth of a whole rectangle, that is three of these pieces. They're not pink, they're just pieces. Now, however, when I look at it as an instruction, I need to take away three pink pieces. So we have left 7 pink pieces. So in order for me to figure out what the fraction is that I need to take away in terms of number of pieces, remember we're translating this to integer subtraction that we then do, and then we translate back to fractions. In order for us to do that, the fraction is in reference to a whole, and I just need to look at a standard rectangle to figure out how many pieces is equivalent to 1/5 of a whole. Then I come back to my instruction aspect and say, okay, so I need to take away 3 of these 10, and I'm left with 7. Now my standard sentence, not pink. How many times is that going to happen? Many, many times. It takes how many pieces? It takes 15 pieces in general to make a whole rectangle. So take note of when the pieces are colored, when the piece is not colored. All of that helps me. It takes 15 pieces to make a whole rectangle. We have 7, so or let's say we end with 7/15 of a whole, of course. We had some portion of a rectangle, we removed some of it, so we have a little bit less. Let me zoom out a little bit, or I can fit it all in. Okay, so I just want to do one subtraction. It's very similar to addition, but that could make it more difficult, I suppose, because I want it on the intuitive level to be very different from subtraction. So my presentation should work with the instructions that I have in this case. It's not addition. I'm not going to do the same thing. For addition, I see both of the numbers or both of the quantities and then I do something. For subtraction, I don't. I only see the first one. The rest is an instruction of how to modify that. And it doesn't make sense to me. It doesn't make sense to me to see the second quantity separately. It doesn't make sense. It doesn't fit with the intuitive instructions of subtraction. Now I know that mathematically speaking, there is no subtraction, but this is not what we're doing. Remember, we are staying as left as we can. So we'll do the other examples. We'll do them next time when we continue our discussion on fractions. But we will stop here for now on this topic. We're not done. There's a lot more to do. And then when we're done with that, we'll talk about shortcuts and how how the diagrams suggest the properties and shortcuts as well. But for now, let's have a look at the schedule. We have our quiz 3 on Monday. Quiz 3 is going to go all the way up, not all the way. It's part 3. And part 3 is, I don't know. Let me get my mouse here. Part 3 is divisibility and modular arithmetic all the way and everything in between. So there are divisibility chapters, prime numbers, factors and multiples, models, number line model and chip model, and modular arithmetic. 5, 1 page for each. Couldn't be set up nicer. All standard stuff. Look at the examples, look at the problems. We're not really deviating much from that. I don't think there's going to be any question that you're going to say, "Oh, I've never seen this before in my life. This is such a surprise." No. If we've done two of these already, two quizzes. If you do your homework, studying the examples and the problems, and pay attention to what we talk about, there is no surprise. But you can tell me if there was any surprise in the first two quizzes. I don't think so. But it is important to present your answers. You can focus on that instead. Presentation is key. Show your thinking, show your work. Many people are losing marks because they just write the answer and I have to magically know what's going on in their head. No, it has to show on the page. Write more than what you think. When in doubt, write more. If you're not sure, "Ooh, is this enough?" The answer is always no. It's not enough, write more. Write words. You have a ton of time, I think, especially because you have 30 minutes to scan and send it back, and you know how to do that now. You've got a lot of time. Write words. It makes it so much easier to grade. Then I can verify that you know what you're doing, and there is no doubt, and I'm happy to give you all the marks. But it is up to you to present your answer in a convincing way. Are there any questions about the quiz? What's coming up? What to expect? Anything at all?
I just noticed that there's a spot for the oral test today from 3 to
Yes,
4.
today's Friday, 3 to 4, absolutely. Yeah. Now,
Okay.
I did accidentally, well, something came up on Tuesday, and I didn't say that I wasn't going to be there. I apologize. I will be there today, 3 o'clock. Also, Sunday morning, if you're into getting up, well, it's not that early. So, all of those blocks, you can just drop in, do your test. It takes like 5 minutes, uh, but whenever you want, yeah, today would also work. Absolutely. All right, if there aren't any other questions, then we will end. Oh, there's one more typing. Let me just double check before we end our session. She is typing. She is typing. She typed. All right. That is it. No, more people typing. You don't have to stop. Fractions are so much fun. I know. The are. I know it's stressful, but I I don't think so. Everyone looking back after they've done the test, like, oh, that wasn't bad at all. If you know what's going on, the questions are all straightforward. It's supposed to be you answer immediately. There's no calculation or anything. You're not supposed to have time to go and look it up. You either know or you don't. And for that reason, they're going to be very basic, very basic. Ask people that have done it already. It's basic things, basic, basic. Um, I don't know of a date for the final exam yet. It is the time. November is the time. I'll have a look. I don't remember getting an email with the final dates yet. It is the middle of November, so it should definitely be up. But if you can't see it when you log in to the college system or wherever you go, Camlink, then it must not be final yet. But it is surprisingly late. You're right. Yeah. So have a look. See if you can find it. I'll double check my emails. Yeah. All right. Let us end the lovely discussion. We're going to do a lot more fractions. If you're a little bit unsure now, like, I don't know, we've only done three addition and one subtraction. It takes time, it takes repetition. So don't worry about it too much. Focus on the quiz, and next week we devote pretty much the whole thing. Yeah, pretty much the whole week for to fractions because there's a lot to think about, and it's very important to start a discussion of fractions. Start it right. Get little Timmy to feel good about fractions. Very important. All right. Until later.